everybody! Welcome to our week 8 quiz tutorial. This week, you guys did some division and then did a cumulative review. So for your quiz this week, we did some division and then did a review question. The first division problem is dividing by a monomial. It's just a single term by itself. Whenever you're dividing by a monomial, you just divide every single term by that and simplify. So what that's going to look like for us is going to be 3x squared y, we're going to divide that by 6xy, minus, we're going to do 6x to the third y to the third, and divide that by 6xy, and plus the last term, which is 12x to the fourth, and we're going to divide it by 6xy as well. Okay? So then simplifying, the 3 and the 6 are both divisible by 3, so we can simplify 3 6 to 1/2. With the x squared and the x, we can divide out one of the x's. So then we're just going to be left with an x in the numerator. And then our y's are going to divide out. So that first term simplifies to x over 2. Our second term, we can divide by 6. We can divide out one of the x's. So then that'll be x squared. We can divide out one of the y's. So then y to the third divided by y would be y squared. So that second term simplifies to x squared, y squared. Plus, in our last term, 12 divided by 6 is 2, or 2 over 1. X to the fourth divided by x would be x to the third. And the y still stays in the denominator. So our last term will be 2x to the third over y. And this right here is our answer. The next one I asked you guys to do was 2x squared minus 4x plus 9 divided by x plus 3. X plus 3, it's not a monomial, it's a binomial, which means you have to use long division. You ready? So we're going to do 2x squared minus 4x plus 9, and we're going to divide by x plus 3. Long division for polynomials actually follows the same steps as regular long division. So the first step we're going to think about is that first term, which is x, times what? Gives you 2x squared. It's kind of how many times does it go in? How many times does that outside number go into the inside? Okay? So x times 2x would give us 2x squared. Just like regular long division, that 2x goes on top. The next thing we're going to do is multiply. And you'll multiply by the entire thing. So in case you were concerned about us not using the plus 3 before, we are now. We're going to continue using it. So 2x multiplied by x plus 3 would be 2x times x, 2x squared. 2x times 3 would be a positive 6x. Okay? The last thing that we're going to do is subtract. And bring down our other terms. Okay? So when I subtract, you do have to subtract everything. And be really careful with this, please. This is one of the steps that people make a lot of mistakes on because they're rushing through. The 2x squared minus 2x squared would be 0. Those first terms should always cancel out if you did your job right. Then we also are subtracting the 6x, so if it helps you to bring it over here, great. We have a negative 4x minus 6x, which is negative 10x. And then I'm going to bring down my last term, which is a plus 9. And then you repeat the process. Instead of getting a 2x squared, now we're thinking x times what gives you negative 10x? Well, x times negative 10 gives me negative 10x. And so we're going to put that on. Then we go to step 2, which is multiply. Negative 10 times x is negative 10x. Negative 10 times 3 is negative 30. And then you subtract. So negative 10x minus negative 10x is 9 minus negative 30. Well, minus a negative is the same thing as adding. So if you want to put a little plus there to help yourself out, go for it. 9 plus 30 would be 39. And that is our remainder. You know that you have a remainder when you have fewer x's than you're dividing by. Okay? So that 39 is our remainder. It is positive, so we're going to add it. And with the remainder, what you do is we're going to put that 39 over what we're dividing by, the x plus 3. In regular division, this would be like having a 1/2 or a 3/4 or something like that as a remainder. You'd have it as a fraction. So we have it as a fraction too. It's just that our fraction happens to have a variable in it. And up here is your answer. So your answer should be 2x minus 10 plus 39 over x plus 3. The last one I asked you guys to do is a review question. In case you're curious, it's from the last section in chapter 2. If you want to go back and look at anything, you're welcome to do that. This is a compound inequality, so it has 3 sides to it. We have a left side, a middle, and a right side. So when you're adding to both sides, really you're adding to all 3 sides. So we're trying to get x by itself. So first thing I'm going to do is get rid of that minus 2. So to get rid of minus 2, I'm going to add 2. And I need to add 2 to all of my sides, to the middle, to the left, and to the right. Okay? On the left side, negative 5 plus 2 is negative 3. We're going to keep our signs the same. We'll have a negative 3x in the middle. The minus 2 and the plus 2 is going to cancel. It's less than or equal to 4 plus 2, which is 6. Last but not least, to get my x by itself, I need to get rid of the negative 3. They're multiplied together, and the opposite of multiplication is division. So I'm going to divide by negative 3, divide by negative 3, and divide by negative 3. You'll notice I'm doing the same thing on the left side, the middle, and the right side. So on the left side, negative 3 divided by negative 3 is positive 1. My sign is going to flip around, so instead of being less than or equal to, it's going to be greater than or equal to, and I switch my sign because I'm dividing by a negative number. Okay? In the middle, negative 3 divided by negative 3 is 1, so now I've got 1x. And on the right side, my sign is going to switch again because I'm dividing by a negative. 6 divided by negative 3 is negative 2. So now I've got 1 is greater than or equal to x, which is greater than or equal to negative 2. If it helps you to separate it out, what this means is that 1 is greater than or equal to x, or if you like to put it as x is less than or equal to 1. And it also means that x is greater than or equal to negative 2. If you like separating them out, you're welcome to do that. In our graph, what that's going to look like is x is less than or equal to 1, so at 1 I'm going to have a bracket, and it's less than, so it's going to the left. Okay? I'm also going to have x is greater than or equal to negative 2, so I'll have a bracket at negative 2, and it's greater than, so it's going to the right. So my overall solution for when it's both things at the same time will be a bracket at negative 2, a bracket at 1, and everything in the middle. So that's what satisfies my inequality. I do use brackets because of the or equal to. If you are one of the people who likes to use dots, it would be a filled in dot. You could do filled in circle here, filled in circle there, and everything in the middle. That works as well. Okay? In interval notation. Interval notation is where we start using brackets and parentheses, and that's actually why my math lab has you guys doing brackets and parentheses on your graphs to help you all with your interval notation. In interval notation, you look at how far left does our graph go. So my solution starts on the left at negative 2, comma, how far right does it go? Well, it stops at positive 1. I'm going to have brackets at both of them because they're included in my solution and also because they have an or equal to. If it was just greater than or just less than, you would have a parenthesis instead. Hope this helps you guys, and hope you guys have a wonderful week.